Okay, welcome everybody as everyone starts to fill into the arena, shall we say, tonight. I feel like we're doing kitchen, what's it called? Not Master Chef, the Chef Battle show. Anyway, welcome to week 2 of Introduction to CompTIA SecAI Plus. Now, normally I would just turn off my mic and let you all come in for a couple of minutes and have a couple of minutes of silence, but I think this week we'll do a little bit of the intro pretty much straight up front because people will come in pretty quickly, and I've got a bit to say, and I really would like to get time for George to get back into it as quickly as possible. So, as I said, welcome to week 2. As you know, this is a free short course presented by IT Masters in conjunction with Charles Sturt University. My name's Shane Murphy. I will be your MC for tonight's webinar, and was last week and might be in a couple of weeks' time, but next week I'll also introduce Terry Magilakis from our team, who will be hosting next week. He's here to learn and to figure out what it is, that we do in these crazy evenings that we spend together. We welcome to you all tonight and hope that you're safe and sound and well and all rugged up or got the air conditioning on, whether you're in Addis Ababa or in Adelaide. Remember to say hello in the chat to us and keep the Q&A for questions for George specifically that he can answer about the course content. I can see that everybody's saying hello already anyway. I hope the audio is not echoing to everybody. I'm sure somebody else will tell me if it is. Um, as you know, we use Zoom. We don't use the hands up, so please be aware of that. We will just cancel your hands up. Please put the questions for George in the Q&A and all other comments in the chat. Remember to focus your chat on everyone rather than host the panel so that everybody can have it. And feel free to chat amongst yourselves on the chat as well as to us. Tonight, of course, as always, we have Lil here looking after the chat, and Lil will be providing answers to questions like, is this being recorded? Yes. And where you can find the recordings, when we'll have them up on air, all of that sort of stuff. We will have Q&As sometimes during the middle of the conversations and always at the end as well. If it's particularly pertinent, I will occasionally interject during George's presentation. For those of you who haven't heard anything about us before, and this is your first thing, IT Masters are a training organization, and we exist primarily as a partner to Charles Sturt University, who we work with to create and deliver a number of master's courses, mostly in IT. Our model actually is unique. We don't believe anybody else actually does the same things that we do. Lots of people work with universities. We do it in a particular way that is unique to us, and we've been doing it for over 22 years now. We do these courses for free because we think if we do good courses for free, that gives you an idea of the quality of what we do in our paid postgraduate degrees, and it might encourage you to sign up with us at some point. We also think in itself, it's a good thing to be giving away some education as part of what we do. With that said, we want this to be a useful and rewarding exercise. We want you to learn some interesting stuff, have fun, and hopefully make connections. I think there's about 2,000 people enrolled in this course. Usually about 10% of them turn up to at least one of the live sessions. So you'll have plenty of people to chat to. Remember to trawl through all the discussion forums on learn.itmasters.edu.au as well and say hello there too. There's a lot of people that don't come to the sessions but actually do go to the discussion forums. And our experience has been is that you actually often know a lot more than us who are attempting to teach this stuff. So there are people in there who will have specialist skills and specialist knowledge, and hopefully they will share it with you all. Lil is also responsible for anything else to do with the short course site. So if you've got any problems, you email to shortcourses@itmasters.edu.au and Lil will answer, figure out things like passwords you can't get in, make sure the materials are up on the website, all of that sort of stuff. This week, a little bit later on, I'll do the obligatory advertisement about what we do. I'll hold that over for a little while. But also tonight, I thought I would just reiterate something that I said last week and make a bit clearer. We are currently allowing 25% off all of the CompTIA products and only CompTIA products that are on the ITM store. That's going to be on there till the end of May. It's all been put in place. We have about 12 or 15 certifications and associated courses. on the store. But if you come to us and there's something you particularly want, some variation of them that you've seen somewhere else, we can actually get nearly all of them anyway. So feel free to ask us if something that you want is not there. To obtain the discount coupon code, just email us at shortcourses.itmasters@itmasters.edu.au, or alternatively, you can see on the ITM store page, there's a discount request, and you can fill that in and put a note in there. Particularly if you want a different course or something, you can actually put a note in on that. Anyway, please say hello and stuff. And oh, I was going to start this poll, which I will do just now as well, just before George comes on. What do you think is the biggest challenge that AI presents to cybersecurity? And I put up a couple of things. Security arms race gets worse. The cost and risk of cybersec blowout. There's creation of many more unforeseen attack vectors. Security breaks down altogether. Or put a comment in the chat if it's going to be something else. Having said all of that, we'll let that go along in the background, and I will hand over to George. Thank you so much for listening to me for those couple of minutes, and welcome again. How are you, George?
Hey Shane, wait, did I come on? So I think I can't see myself, but I assume you can see me. It's funny actually when you talked about the weather and being rugged up or having the aircon on, I laughed out loud because I think on Sunday here, and I'm in Melbourne, and I saw there's quite a few folks from Melbourne, that it was so cold on Sunday morning. I went out for a bike ride at like early and it was like 3 degrees. And then the last few days it's been very balmy in the evening that I've almost needed the air conditioning. So, but it is Melbourne, so probably expected, right?
There is the Four Seasons in One Day song specifically for that.
Yeah, yeah, exactly. So, yeah. Um, well, I might as well get. Should I wait a moment for you to finish the poll?
Oh no, let's just leave it up there for a while, and when you got a bit of a break, we'll have a look at the answers. I'd be
Okay,
interested to see.
awesome.
Yeah.
Well, let's get going then. So, welcome back, everybody. Back to, well, week two. So I'll go to the next slide. So here we are. So last week we did a bit of a overview on some of the basic AI concepts related to cybersecurity. And this week we're going to move on to securing AI systems. And again, as we've sort of reiterated that, this is really an introduction. We're not going to go too deep into the content. If we did, we would be here for much longer than, 45 minutes to an hour. And certainly, if you do decide to take a look at SecAI Plus in a bit more depth and want to sit the exam and so forth, then there's obviously some further study that's definitely recommended to look at that. But yeah, today what we'll do in terms of securing AI systems is it's sort of broken into, I guess, loosely two parts. The first part will focus on the threat modeling piece. And then we'll start looking at some of the actual controls that can be applied to, mitigate some of those risks, I guess is the word that I'm looking for. So with that, let's talk about threat modeling. So anyone that's, from I guess, well, look, probably many fields, but certainly from the cyber field, and as many of you know, my background's been in, tech and cyber for many, many years. Threat modeling is something that's very familiar to me. Basically, at a high level, it's that kind of structured approach to being able to identify security threats, and it's about identifying those threats, kind of measuring what sort of impact they may have on a particular, what we say normally, particular system or application or network or whatever. In this case, obviously in the context of AI. And then what we do is we take this really from almost an attacker's perspective. So if you look at it from the perspective of a threat actor, and what they're thinking, and kind of put yourselves in their shoes, it really helps to identify, what vulnerabilities there may be in these AI systems, which then allow you to address those early on. Because what you don't want to do is, well, what you don't want to do is not identify, a lot of double negatives here, not identify those particular vulnerabilities, not do anything about them, and then you go live, and then a threat actor, finds those vulnerabilities and exploits them. And so, really, here when we talk about this, what we're looking at is how to apply threat modeling in the context of AI, right? And so we're specifically looking at things like data sets and models. We're looking at things like prompt templates, plugins, all those sorts of things. And using, AI in cybersecurity does introduce some new risks. And so that's why it's really important to get this right and to do this, threat modeling, and help, yeah, as I said, spot those vulnerabilities before the attackers spot them and exploit them. So I think the thing that's also really important to understand here is that this is not just about creating a list. So more, often like many things, and as I said, I've been around a while and I've done a lot in the kind of, GRC space as well in terms of the, governance risk compliance stuff. And I've done a lot of work, and we're just talking about this before, weren't we, Shane, about ISO. Um, there's a lot of this whole thing about, box checking and just kind of just doing exercises for the sake of, for example, trying to get certification and maintain it. Again, that's not the idea behind those standards. But similarly, the goal here is not just to create a list, not just to create a list for the sake of creating a list, but you really need to identify those potential, I guess, threats. You need to tie those threats to owners. You need to work out what controls need to be applied to those threats, and it's really a critical part of, I guess, good risk management. So that was the overview on that. So if we move on, if we look at, some AI specific risks and threats, um, you know, we can see it here. There's some new attack surfaces and new attack types that kind of, appear when we start to look at AI. Things like, model behavior and training, the different prompts and conversations that can be had, and then also things like plugins, tools, external APIs. For example, prompt injections that, bypass, I guess system instructions, things that can potentially leak sensitive information and secrets, or things that can unintentionally, like models that could be trained to unintentionally reveal, customer data, are all things that could be, potential risks of using AI. We've also got down here, so it's a little bit tiny for me on the slide, but think about sensitive data leaks. So we talked last week about the whole Samsung thing, right? And if I think about some other examples of this, and this is something when I try and relate it to the work that I do. One of my businesses, we develop GRC software, and there's AI capabilities in it, right? And the platform has the ability to be used across like multiple teams, and there's permissions applied and all that sort of stuff. So when building out the AI elements of that platform, I need to make sure that I'm not, or that the AI is not inadvertently disclosing something that someone isn't meant to access. So these are the sorts of things that need to be thought about, when looking at those AI specific risks and threats. Because, often when you look at that, well, when you look at AI is built off the back of data. You can't have AI without data. And so, I think I said that a few times, maybe not the last couple of weeks, but I've said it a lot in the past. So data is crucial. And for it to be useful, it needs to have the ability to access that data and to consume all of it, but it needs to also respect any particular access controls that are in place and any particular roles and permissions that are in place. And so we need to identify those things, think about them, and then create treatment options to deal with that. And that could be things like, sanitizing training data. It could be putting in strict access control checks and those sorts of stuff. And we will go through that in a little bit more detail shortly. So if we look at some, threat resources, these are almost like lookup tables for AI risk, and these can be used to complement frameworks. And we've got, what we've got here. So there's some key resources down the bottom here. We've got the MIT AI Risk Repository, the CVE AI Work Group, the AI Vulnerability Database, or AVID, the AI Incident Database, and I'll go through a couple of these, or AIID, and AR Arxiv. And so, I think it's important to understand that as AI adoption grows, the the attack surface and the attack vectors expand. So we really need to keep a current picture of what the current and emerging threats are. So these repositories and these resources really help to, support that proactive, I guess, design and incident response. So if we look at something like the MIT AI Risk Repository, it's effectively a live database of AI risks. And so within there, there's about 1,600 odd risks from multiple frameworks. It includes things like title, keywords, any evidence sources, and then sort of a classification into risk categories. So that's first one there, the MIT one, so obviously out of MIT. We also have one that's pretty interesting, which is AIID. So this is the AI incident database, and this one is really important. This focuses on incidents that actually happened. So these aren't just theoretical risks, these are actual responded to discovered incidents. So, you know, definitely if you haven't seen it before, definitely go check out AIID, so the AI Incident Database, and look for some scenarios that may, and again, if you're a practitioner or have AI in your own environment, look at scenarios that may resemble your own environment or sector. So, maybe you're in financial services or maybe you're in manufacturing or whatever. Have a look at that database to see if there's any examples of when an incident in that sector may have occurred, and see if there's any potential risk in your own environment. It's also a really good way to help build training for analysts and so forth, for red teams, and even for demonstrating uh, you know to boards. And so I've used in the past one of the I don't know if I use the right word here, but when demonstrating the why, as in, does the why something is important to a board, it can be helpful to include examples, especially examples that are relevant to the industry or sector that you're in. So the fact that there is a database that exists that may in fact have examples of actual incidents could be valuable. So definitely check that one out. So when we think about threat modeling, there are some prerequisites for threat modeling. One is that you really need to understand your environment, and you really need to understand. Look, again, as I said, I do a lot of work in the ISO space, so it's about we, as an ISO practitioner, I talk about context of the organization, and needs and expectations, and stakeholders, and those are all very relevant for this. So context being, what does your organization do? What does the AI do? What use cases are you trying to use it for? And then talking about stakeholders and so forth, like, do you have any regulatory requirements? Those sorts of things. So if I step through this, we've got AI and ML architecture. So where are your data sources coming from? Um, you know, Basically, what sort of endpoints and APIs do you have? If we look at things like security policies, so what sort of security policies need to be applied? It's pretty easy to go and implement AI or adopt it, and well, kind of full stop. But you need to consider what organizational security requirements may be there. If we look at some pretty key examples here, we've got data classification and retention. So in other words, what type of data is it? How long do you need to keep it for? What are the requirements? For example, do you need to classify it as confidential or sensitive, or if you're in government, secret, top secret type stuff? Um, Again, that yeah. Anyway, and also, are there any retention requirements? So, for example, if you're collecting information that's going to AI, do you need to make sure that it's removed after X number of time? And those will need to be applied. So those organizational policies will need to be applied in the context of AI as well. Also, looking at things like secure development standards. So, and it is again very similar to anyone that has worked in the. Oops, sorry, that was my elbow. Um, what's happened in a cyber field, where if have worked with developers and you're doing secure coding, and you're using parameters and things like that, it's the same. So do you have some organizational policies around that, and how do they get applied to AI? And then finally, as I said, we've got some regional regulations and compliance. Now, the material here is from SecAI Plus. They explicitly call out GDPR, which is the EU General Data Protection Regulation. So basically the privacy regulations, legislations in the European Union. Obviously, in your own jurisdiction, there will likely be different ones. So, for example, being in Australia, then Privacy Act 1988 would be an example of one that would be applicable to us. But yeah, this is obviously from the text material. So GDPR is the one that is mentioned in there. But look, I guess the key thing here is that before you start AI threat modeling, you need the knowledge on the architecture, the threats, the security policies, any compliance requirements, and any and the threat modeling frameworks. And we'll go through those in a little bit more detail. So here you can see coordinate across teams. So AI threat modeling is a cross-discipline activity. It's not just a security exercise. It needs to happen across security, application architecture, developers, architects, again, legal and compliance. Then you've also basically it can't just happen in a vacuum. You also need to take things into account like end user characteristics, data storage processing, all those sorts of things. And what we'll do in a moment is we'll go through a little bit of a high level case study and sort of look at how that could be applied to this. So if we applied it to a case study, so let's look at this. We have a sector, so retail automotive platform. I think this one's from the text. And then we've got AI bots assist users to buy and sell cars. They guide transactions. They estimate resale value from car and engine photos. The old process, so pre-AI, obviously, is that there would be a human who would be on the customer service desk, and they would obviously send stuff in, and there'd be a manual assessment and an assigned representative who would then go through that process. If we now look at a AI-driven process, a bot would now handle most of the customer interaction, and there's less direct human oversight. So if we think about this just from a high level, we're already starting to think about things like who has access to sensitive data, where are decisions, where are they made, and then we talk about less direct human oversight. How are errors detected? So think about what new risks might this introduce compared to the old process, as in this being the AI-driven process compared to the old process. So I'll pause there for a moment while everyone thinks about that, and then I'll move to the next piece.
Would you like me to talk about the poll for a minute?
You
Talk
could do that, and I'm going to
break.
have a sip of.
Okay, so we'll end the poll. I can never remember with these whether you see the results while it's there, but I'm going to share the results now anyway. More than half of the respondents said that creation of many more unforeseen attack vectors, which sort of makes me think that it's a little bit like deep blue. It beat people at chess just because it could do everything all the time, everywhere, all at once. Some of the other responses from people saying, here's some other ideas. Biggest challenge for AI I can see at the moment is the intersection of all the governance, usage, and actual controls. Users are adopting and using things that are constantly changing, allowing for unknown actions and responses. Trying to pin down the best ways to secure things could you get you pulled in many directions at the same time. So having to work even harder. Biggest challenge for AI in business context is determining a security pattern that you can allow for broad deployment and utilization by various business units. AI bots infiltrating electoral offices and manipulating elections. It's probably already happening, I suspect. Uh, Management and governance of risk. I think the biggest challenge that comes from AI is the mindset of users. The complexity of how they work and are secured means users just assume security and privacy even when they shouldn't, which is interesting. I suppose it always goes back to the same thing, is that humans are always the problem. And the last one that I was able to pick out of the chat before it ran past me too fast was the dwell time between discovery and disclosure of vulnerabilities and exploitation is getting shorter by the minute, it seems. That means that responses are going to be harder and harder. I guess they're all pretty good, actually.
Excellent. All right.
Uh, but yes, I will stop sharing the poll so it's not in everybody's face for a while. But thank you for your answers to that.
I shall carry on. So, um, so looking at some of the, so I was to think about that, but let's looking at some of the data, thinking about what data is collected, how there's sort of interaction, how it's handled, some of the compliance considerations. So, if we look at some of the data that could be used to train, sorry, still on the case study here, but car types and features. So, is it a station wagon that has all-wheel drive, for example? Engine manufacturing details, any historical resale values, very important, right? Because if you get a car that depreciates like crazy, as many do, they want to make sure that they're providing, good assessments and valuations. Um, what could a user, submit as part of this? So think about um, things like car and engine photos. Funnily enough, I was actually, and when you kind of see this thing pop up and like, oh, that's interesting, and it popped up for me earlier. It was talking about like it was actually similar. It was kind of like you want to sell your car, and we'll give you like a price. But it kind of to me it was like, oh, it's getting complicated, so I just kind of bailed out. I was just curious as to what I might get for my car, but because it did this, it went like, oh, what kind of car is it? How much mileage is on it? Obviously, what year is it? They also collect the rego, which they help to pre-populate things. And obviously, a lot of this isn't we're not getting to AI yet in this. What I'm talking about, this is just kind of very basic, data collection and probably some API calls. But then it was like, oh, get take some photos. Now, by the way, I don't know if this then goes to AI, whether somebody manually does it, although they said it comes back pretty quick, which makes me think that there might be some level of AI used in it. But vehicle identification numbers, driving licenses, lease agreements, all these sorts of things. Now, if you look at some of this stuff, I can already see that some of these things would be considered, personal information type artifacts, which would fall potentially under, various types of privacy legislation or compliance requirements. And so if we start looking at this will, I guess, almost set the stage for some of the kind of later steps around threat modeling. So identifying which assets are most critical and where attackers might focus on. So, for example, I'm really thinking, well, if I was a threat actor and I was trying to attack this particular system, I'd be going for the sensitive stuff, right? The crown, what we describe often in cyber as the crown jewels. So things like, VINs and driving license, or driving licenses, probably more specifically. Those are the sorts of things. Um, you can see on the right here, it looks like there's some, mention of data handling and some um, almost potential control type stuff in here. So encryption in transit and at rest, input validation, integrity checks. These are all things that would need to be considered. And then, yeah, looking at compliance considerations, so personal and financial data. GDPR and AI specific rules in the EU. Um, so, um, what does that process look like? So gather prerequisites and assets. So what is the business use case? So how is the AI going to be used? What is the process flow? So how does data flow from one end to the other? What kind of happens in between? Collect things like architecture diagrams and data flows. Look at what type of data is collected. How it is processed, where it is processed, those sorts of things. And also look at who uses the system and where is it deployed. So by who are the people that use the AI? Is it just someone internal? Is there external interaction? Um, is it deployed in the cloud? Is it deployed on premise? Those sorts of things. And then also look at the most critical assets. So this goes back again to that personal or regulated information. It also looks at some of the trade model and decisions, because remember, there are other things around bias as well that need to be considered. There's some ethical things that need to be considered as well when we're talking about this threat modeling piece. I find that AI is an interesting area because it probably, for me, feels like one of the most complicated, especially as a kind of practitioner in the space. It's probably one of the more complicated things. Like it's not just clear cut. There's a lot of things that need to be considered, and they need to be considered based on things like use cases and context and requirements and so forth. Um, and then look at the threat modeling frameworks. And so if we look at, if I try and apply some of this, assets, we've got PII and documents, we've got photos, we've got pricing models, we've got decision logic. If I look at some of the frameworks, you know, OWASP top 10 for LLMs might be useful. There's some, I guess that might help with prompt and model misuse. There's also some others on here, and we will touch on those in a moment. I think we're going to touch on probably at least the first two or three. I see Stride is mentioned down there as well, which I thought, is so Stride is the one that was developed by I think it was Microsoft. I see that the reason I mention that is because it's used often in InfoSec. So Stride being spoofing, tampering, repudiation, information disclosure, denial of service, and escalation of privilege. This is being applied, and I say that because there's obviously overlap between, just more broadly cyber and AI, because a lot of these things are relevant. Many of you may be familiar with OWASP. And as I said, I'll talk more about the OWASP top 10 for LLMs and ML in a moment. A lot of people will probably be familiar with the OWASP top 10 for like web security, web application security. And then, yeah, MITRE and NIST. So again, all probably well known to many of you. Um, if we look at, identifying and categorizing threats. So think like an attacker. So this is where, thinking attacker versus defender, um, you know, consider things like how you might break the system, how you might manipulate it to, do what it's not supposed to do. Yes, hack it, basically. Obviously, you wouldn't do this in a production environment. This is still modeling. This is still before. This is all planning type stuff. And then map those threats to those frameworks. Um, so, for example, like a bot could jailbreak the system, and I guess lead to access of PII, car photos or other user information if those access controls are weak. We also could have a potential. Again, let's look at the regulatory landscape. So if we have uh, you know EU persons involved, and there are some legal implications here in terms of whether the solution is intended to be providing services to EU people and all those sorts of things. Um, that's where that coordination with the legal team and not working in a vacuum is important. But say that there's a PII breach that leads to or PII breach in the EU that leads to legal and regulatory penalties for the organization. that could be something that would need to be addressed. Um, the other thing is threat modeling is not set and forget. It is meant to be iterative, and they must be, those controls should be tested and reevaluated, you know, iteratively. So, oh, it's hot in here. So step five, recommend and document controls, and step six, validate and iterate across software development life cycle. So here we have things like recommendations, to do things like, for example, in the case study scenario, strict access controls, parameterized queries. That's what I was talking about before. When you think about some of those things that would be part of a secure development, process or secure coding. So parameters to help minimize injections, um, instead of direct access to back-end systems and things like that. Very, very similar to your typical cyber hygiene controls. Those types of controls should be implemented as well. Doing security testing and assessments at each stage. Again, very good cyber hygiene type exercises. Rerunning the threat modeling after major changes. So yeah, there's going to be things like fixing security patches and stuff like that. Maybe there's no need to do a threat modeling exercise when that happens, but say there's a fundamental material is what I was looking for, a material change to the platform, then you would definitely consider running threat modeling again to see if there's any new threats that you may identify as a result. So let's look at some threat modeling frameworks. So we'll look at, I think I mentioned OWASP, MITRE, and maybe NIST. So basically what these are, if anyone, again, that's familiar with OWASP, MITRE, and NIST, you've probably heard those terms before. Um, Although OWASP, MITRE, and NIST really kind of refer to that high level, almost, what's the word, organization, publisher, body. And then you've got the sort of frameworks that sit under that. So threat modeling frameworks are really those sort of structured, I guess, well, structured frameworks, methodologies that are used to, I guess, identify, categorize, and help deal with these vulnerabilities. So if we look at the OWASP top 10, OWASP is the, someone put in the chat, maybe Open Web Application Security Project, maybe. Sorry, so many acronyms, isn't there, in tech? So OWASP, as I said, many would potentially be familiar with the OWASP top 10 for web security that's been around for ever. I remember dealing with the OWASP top 10, I don't know, 10, 15 years ago. Um, they've now got the OWASP top 10 for LLMs and ML, which we'll get into in a minute. And OWASP actually have a broader OWASP Gen AI security project, which you can go to. It's genai.owasp.org. And the OWASP top 10 for LLMs and ML really focuses on cyber practitioners. Other parts of the bigger project are for C-level and data scientists and things like that. But we're going to be focusing on the cyber practitioner piece, which is the top 10 for LLM and ML. And if we look at how we can apply this, have a think about how you can apply these to the case study as well. I'm not going to go through that just in the interest of time. But, there are these 10 controls. So here are the first five, and I keep looking over there because this preview is so tiny that I can't read it. Prompt injection, and I'm not going to just read the whole slide out, so I'll just read the control. Prompt injection, sensitive information disclosure, supply chain vulnerabilities, data and model poisoning, and improper output handling are the first five. And again, think about how that might apply. So, prompt injection, for example, could cause the bot to ignore pricing rules, which then could result in an output of manipulated prices, which could, throw things. And then again, that would apply to LLM 1 and 5. So, that's how you could apply that. Supply chain vulnerabilities. I mean, again, we don't know. Probably not enough information in the case study to answer that one. Like, who's like, are they leveraging somebody else's AI? Where is it living? Is it living in a data center? Are they using a third-party product? That would all come down into sort of the supply chain piece. We're not really covering that too much. The following five controls, so to bring us to 10, excessive agency, system prompt leakage, vector and embedding weaknesses, misinformation and hallucinations, and unbounded consumption. It's funny, LLM9, has anyone ever experienced AI hallucinations? I certainly have, man. I remember, probably not so much recently, but I remember at the beginning, I was like, what is it on about? That was something, and it still is an issue, but certainly, you don't want it doing things like that and just simply making stuff up. Um, I know someone mentioned, I think I saw model theft popping up before, but um, oh, that's strange. No, that's right. Sorry. I was looking at the next slide. I was like, what's happened there? Um, so again, think about how some of these might apply to the case study. So this is for LLMs, so large language models. If you talk about machine learning, there is an OWASP top 10 for machine learning as well. There is a little bit of overlap and a little bit of similarity. But there's some related items, for example, data poisoning versus model poisoning, versus model skewing. Wait, is that over here? Model skewing. So have a look at, again, when you get a chance, have a look at how those are slightly different between those. So if we look at data poisoning, malicious or unvalidated data added to the training set, leading to biased behavior, degraded performance, or hidden backdoors. I think we talked about that maybe a little bit last week, or at least I spoke about it. Talking about the ability to kind of mess with the training sets to create bias and things like that. Um, Whereas if you look at uh, so that's data poisoning. Where's the other one? Model poisoning. That's what I was looking for. Harmful code or data is injected during training or fine tuning, altering model parameters while keeping performance seemingly intact. So as you can see, they're similar but different. And then you've got model skewing. And then again, so model skewing was the one, I think, sorry, that was the one I talked about last week. So MLO8, altered training or feedback data changes model behavior over time, reducing accuracy or introducing harmful biases. So I think that was the one that popped up uh, last week. So we also have the MITRE. So MITRE out of MIT, and you might be familiar with the, you know, attack framework for, again, anyone that's done a lot of work in cyber. The MITRE adversarial threat landscape for AI systems. God, I love acronyms. It is basically Atlas is the attack style framework for AI. That's basically it in a nutshell. And it focuses again on attacker behavior. So if a fraud detection is poisoned with fake user data, the idea here is that Atlas would help trace the techniques and suggest defenses like robust data validation, anomaly detection, and things like that. Um, so that's Atlas. Yeah. And then we've got NIST. So NIST being the National Institute of Standards and Technology. Again, many will know NIST for their cybersecurity framework, or if you're, like me, 853, which is their, and 837, which is their risk management framework for cyber. So they have a NIST AI RMF, which is the AI risk management framework. I don't know the special publication off the top of my head, sorry. But basically, this is a governance and risk management layer. And the idea here is that it helps to ensure that, AI is deployed responsibly and all that sort of stuff. And so as you can see, it promotes trustworthy and responsible AI. It has requirements around safety, security, fairness, privacy, explainability, and resilience. And it's built around four core functions. So again, anyone that's familiar with the cybersecurity framework, it has a similar core functions that I can't remember identify, protect, detect, respond, recover. Oh, and there's govern in there now as well. And so similarly in the AI one, you'll have map, measure, can't spell. That's meant to be manage, not mange, and govern. All right, I'm going to pause there for a moment and then we'll go into security controls. I don't know, Shane, if you've got any.
There's a couple of questions, and I would suggest that it's good time for people to bung some more in there, as always. Um, okay. I guess there are vendors out there like Microsoft that keep trying to sell its Purview Suite, Security Copilot, etc. However, I wonder if there's a semi-automated way, automated way to do data classification labeling, as most organizations right now struggle to do that for data posture management. Seems to be a very big challenge. Data is getting generated more quickly than they can be classified, particularly sensitive data. My understanding is if you cannot even classify the data and label them due to its sensitivity, then you're not ready to use AI for anything.
I hear you. Yeah, that is definitely a challenge, and I've had many challenges over the years around how to well basically label data. And so for anyone, talking about data classification and data labeling, it's about understanding, you typically will have a classification scheme. So what is the based usually on sensitivity. So for example, the least sensitive being, what is usually described as like public data. So there's not really any, I guess, material impact if that were to be disclosed to the public, all the way up to whatever the most sensitive classification is. So that could be, confidential or whatever. In government, it would be top secret. But the point here and the question that I think, if I understand it, is like how, I guess what is an approach to doing that? And you're right, like, Purview is one of the tools that does have the ability to do that, and Microsoft will obviously try and sell you that. There are many other tools out there that do it as well. But I do wonder, what sort of level of kind of, false positives and things like that you have. And it does kind of make sense that maybe AI is going to be the way forward. Like, can AI identify the sensitivity of a document, classify it, and then label it? Because historically, it has been, yeah, I mean, previously it has been manually. Interestingly, again, sorry, I keep talking about ISO, but there's a control in 27001 that talks about classification of information and labeling of information. So it's about understanding your assets, understanding how sensitive they are, and then labeling them. And so a lot of the time, it might not even be getting down to the granular level of saying, oh, okay, well, this particular document is this and this is this. Maybe it's more a high level, and this particular system is labeled. But yeah, look, I don't really know the answer to the question. Other than that, it is a challenge. I've had the challenge. You know, um, I don't think there's a silver bullet for it yet. Maybe AI is it, but at the same time, again, it's really important to understand the risks of using something like that where it will have access to everything. Um, I think I just went off a complete tangent, but
Okay.
sorry.
Actually, Yvette in the chat said that there are tools that can do that. AI tools. Varonis make an interesting set of products around this. If you point to the file server, it figures out what's sensitive and applies classifications.
Yeah, and not to plug them, but I think they do this like free thing too.
Yeah, there you
They've called me a few times in the past.
go. I think you mentioned that Australia doesn't have a specific AI Act and the existing privacy acts and other acts cover for it. Wouldn't companies benefit from having some sort of standalone AI Act to assist with their GRC?
Oh, there's a bit of a, what's the word? I can't think of a word.
Somebody's mentioned the PSPF. Have you heard of
Yeah, there is the protected, what is it? The government PSPF protective
it?
framework.
Protective Service Security Policy Framework.
Yeah, that one that has all the like, which has all the government classifications and things like that in it. What I was going to say though is yes, we do not have an AI Act. There had been, and many of you again probably familiar with some of the stuff that's been going on there. There was some discussion about potentially having an AI Act. There was also, the voluntary guardrails that were released by the Department of whatever it is, innovation and can't remember, who also have the guidance on ethics and so forth. Those voluntary guardrails, I think, were initially planned to end up being mandatory, but there's been a bit of a, I'll use the word shift in direction. And then at this stage, it looks like everything is kind of not going to go the way of, being kind of legislated quite like that for whatever reason. Um, and yeah, so at the moment, it's kind of like, and I think the from what I and I'm paraphrasing, but it was kind of like trusting organizations to, this might be a bit controversial, but to kind of just deal with it themselves. Um, which is obviously not the approach that other jurisdictions have, right? The EU, when we talk about GDPR, but the EU were the first to bring out the AI Act over there. But to that point, yes, there is guidance and there is reliance on the Privacy Act in Australia. And again, consult legal professional people. Yeah, the guardrails, that's the one. So that pop up. Thank you. Um, you know, I've lost my train of thought. Oh yeah, the Privacy Act is kind of what we I think rely on and how to protect personal information and be compliant with the Privacy Act. The OAIC does have guidance on how to apply the Privacy Act to AI, so that is helpful. That is a helpful thing. They'll say, if you're a developer or if you're buying a solution that has AI, these are the things that you need to consider. So that's useful. Yeah, that's kind of where we're at, but there's no specific act yet. Yeah, here.
Okay.
Cool.
If you're ready, I think we can keep going.
Cool. Oh, how do I get rid of this thing? There it is. All right. Um, so let's look at security controls. So we've done modeling to death. Let's talk about security controls. So AI brings automation benefits and new attack surfaces. I feel like that was in your poll. Look at that. Here's one prepared earlier. Basically, controls need to cover the entire AI lifecycle. So you can't just do one bit. We're talking from start to finish. So if you look at this, um, data collection and sanitization. So the data that goes in, those controls need to be implemented. Um, and anything that shouldn't go into the model should be removed. Plain and simple. If it's almost like that data minimization thing, right? So if it goes in there, then it will get trained off and learned off, and it'll be obviously potentially a risk. Otherwise, if it doesn't need to be in there, get rid of it. Um, Also, it needs to be in the right format. So that's also part of sanitization. And then development of the model and fine tuning, all the way down to logging, monitoring, and so forth. Um, so if we think about this, talk about data collection and sanitization, attackers, and again, it depends on who has access to the AI, but let's say it's externally facing. Attackers could potentially trick the system, they could manipulate behavior, they could alter training data, and that wouldn't be great. Secure AI isn't really just hardening an API. It includes things like data integrity, model behavior, and as I said, that ongoing monitoring. So again, if you kind of relate that back to your own organization, potentially, if you've, working in that space, think about where your AI life cycle is and what security controls do you have in place. Um, and it says, focus on tech security, but also things like access control and validation, misuse prevention, and ethical use. So again, what are you collecting? Do you need to collect that? How is it going to be used? Is that ethical use of that data? And then also going into that compliance and governance piece as well, which, in week 4, we'll get into that in a bit more detail. So, look, this is almost, again, and it's very relatable, similar, it's the same, overlapping with cyber more broadly, which is around having layered security. So it's a bit like that defense in depth, I think we call it, but layered AI security. So you've got model controls, gateway controls, guardrail testing and validation. And the goal here, as it states down the bottom, is to keep AI trustworthy, observable, and hard to abuse. Um, so these layers basically will combine with, not replace, the traditional controls that we aren't talking about today. So things like network, identity and access management, logging, those are your traditional controls. They will be still there, but these will combine with those to, make it harden the environment. And so anyway, the rest of what we're going to go through is going to dive into each of these layers, and then yeah, look at that. Here's a diagram. So if we look at this layered AI security gateway, that's random. Um, we've got the attacker there, pretty obvious because he's got like a eye patch thingy on, not eye patch, like a, it looks like Zorro a bit, and he's got a skull on his shirt. Anyway, so malicious requests go in. He's not the request isn't going directly to the model. It's going through this layered security approach. So here you could see that there are logs, there are access controls, there are guardrails that are in place, or at least boxes that say that. And then there's things like rate limitation, which will, slow down just kind of hammering it. And then after all those controls have been applied, obviously there's a point where that request is now trusted because hey, it's been filtered out from all these dodgy things, and it's going to the model, and then the model is tapping into data, and then happy days. So basically it's about protecting the model, and about making sure that what's going in is valid, also what going out is valid. There's also this concept, I think, did we talk last week about watermarking and fingerprinting? So that was the other thing as well. So the use of things like watermarking to effectively stamp, invisibly stamp, requests to make sure that they've come from authorized sources and those sorts of things are all kind of, what's the word? Good controls to have in place. So if we look at some of the different model-specific controls and how they apply to the different, I guess, what's the word? Deployment models of AI. So if we look at on-premise models, so on-premise models being, self-managed. I'm going to use the term on-premise pretty loosely because, you know, it could be in cloud, but like private cloud type stuff or, your own sort of thing. But basically what we have here is, you've got full control over the data, the training, and the infrastructure is the point. And we've got elements here like things like data lineage. So data lineage is basically understanding where the data comes from. So we say evaluate data lineage, access control, and environmental hardening. So where is the data coming from? Um, you know, how does it move through the environment? How does it change? How is it originally created, collected? What transformations are applied, if any? Those sorts of things. Can you, for example, trace a customer record from start to finish? So when I say start to finish, from the point that the data comes in to the point that it goes through, gets stored, gets analyzed, gets put through the model, and then spits out as some sort of output. That is talking about evaluating the data lineage. Um, then we have things like, access controls, which I think are pretty self-explanatory, and also the environmental hardening. So that's really around, so environmental hardening talks about the infrastructure itself. So patch management, vulnerability management, network segmentation, all those sorts of things, hardening of the environment. Those are all, again, very good cyber hygiene stuff. That's all the stuff that would come under environmental hardening. If we look at pre-trained models, so they're basically, pre-trained models are basically machine learning or AI models that have already been trained on large data sets before you take them, right? So someone's giving you a trained model. They're basically ready to go, but they need to be verified and they need to be assessed. And you need to look for things like bias and harmful content. because they can contain biases from training data. They could have unclear data lineage. So, what data was actually used when pre-training this model? Depending on, again, sources, there could be potential licensing or intellectual property risks, and they could also behave unexpectedly. So they're just some things to consider. So if you see here, community shared models, so again, there's less control over the data that's gone into the model, which is why, as I said, there could be IP issues, there could be biases, there could be all sorts of things. So just be basically, you need to verify them and make sure that they're all good. And then you get vendor delivered models. So this is, as the name suggests, on vendor infrastructure. They've done all the training. They're providing it pretty much like as a kind of service. They've pre-trained it, all that sort of stuff. Again, it needs to be validated. Um, validate that, validate any contractual and regulatory requirements, and make sure that you can get some sort of security assurances or certifications. So, for example, sorry, I'm going to do it again. ISO 42001 could be an example of a security or a certification that they might need. So they've got good governance, risk, and compliance practices in place. There could be other ones as well, but so if we look at some model specific controls, this is about really some things to try before the attackers try it, because that's what you don't want. So this is where you'll start to look at things like penetration testing and red teaming, or sort of same thing, of the models. So things like maliciously crafted prompts or data, attempting to manipulate behavior. Now, as you can see, this all sounds like things that a threat actor would do. Yes, absolutely. So do it first. Um, you know, can you try and make it do harmful outputs? Try and make it do harmful, offensive things. And we've seen examples of that in the past too. But basically, yeah, can you break it before it goes live effectively? So make sure that's part of the testing and evaluation. Um, we also have, you know, um, trustworthiness testing and the model evaluation. So, once the model has been trained on organizational data, then it becomes a critical resource, right? So it's going to know everything. It's all going to be, it's going to have, I guess, learned from that information. So if you think about what a threat actor might do, they might want to try and steal information. They might want to try and reverse engineer it. They might want to try and manipulate the model. So this is where, these testing things need to happen. Thinking about, controls as well. We talk about authentication and role-based permission, session management, all that sort of stuff. And then also, the guardrails and red teaming exercises. I think I will talk about guardrails in a minute, but the red teaming exercises, to try and find again those weaknesses within the model. Uh, yeah, can't remember what this diagram was about, but well, I could see this is okay. So this is doing evaluation, looking for things like bias. Now I know bias, hallucination, those sorts of things. And then down the bottom, you can see some of the controls that are in there as well. So, rate limitation and so forth. All right. Oh, here we go. So guardrails. So guardrails are really almost like, uh, well, yeah, they control the model inputs and outputs. They will basically be configured usually as middleware. So what they will do is they will intercept the execution, um, and they are applied both at the, so talk about inputs and outputs, they're applied both at the request and the response. So when you request something from AI, the guardrail, if it's put in place, will, what's the word, intercept and do whatever it's configured to do. So for example, it might, I don't know, prevent a prompt injection. That might be an example of what a guardrail would do. And then say everything's fine and it goes in to the model provides an output. it will go back through that guardrail and it will check the output and say, okay, well, what's come out, and say it's like harmful content or it's like PII, so say it's like credit card numbers or something, the guardrail will intercept and prevent that from happening. So this is really essential in those real-time interactions, and the idea is to stop unsafe content and requests, so unsafe requests from reaching the model or unsafe content from reaching the users. Um, Organizations will need to have typically custom guardrails tuned for their specific risk profile and their regulations and things like that. So here, as I said, common use cases might be preventing PII leakage. Um, it could be blocking prompt injection, as I mentioned, filtering harmful content, or it could even just be to, enforce business rules. So those are examples of how the guardrails will work. Hmm. Um, this is just a diagram. So you can see the users are putting the request into the application, and then you see the input validation. So that kind of was that teal box. Once it passes that, it goes in, and then there's output filtering on the way out. I mean, the diagram probably could be a little bit better, but yeah. Um, oh, well. So some examples of model guardrails. Sorry, I just talked about this, but PII, PCI, redaction. So things like redaction for compliance. So you can see names, addresses, credit cards, etc. But anything to do with compliance with, GDPR, any other privacy regulation for that matter. Um, HIPAA, again, with anyone that's in the US might be familiar, or maybe even not, but HIPAA is a US regulation, or Health Insurance Portability and Accountability Act. There you go, from my brief time over there. PCI DSS, which is the payment card industry data security standard. So again, these types of guardrails can be used to help comply with that. Prompt injection prevention. So basically, detecting any type of prompt injection, such as ignore previous instruction. That might be something that someone does to try and manipulate the model. So you could prevent that. Jailbreaking prevention. So in other words, trying to get out of the model, trying to break that. And also you've got things to detect like phishing detectors, and you can analyze all sorts of things. So, oh yeah, so down there, so identify and block exposure of API keys, tokens, passwords, and internal URLs, inputs and outputs. So any sort of secret information. Um, Again, one thing to emphasize is that guardrails must be tested. They're not just a set and forget type of thing. None of this is set and forget, just so you know. Um, Wait, no, yeah. Injection attacks. So guardrails can help prevent those injection attacks. So your typical, cross-site scripting and so forth. Detect malware. So if you've got malware in links or code or instructions for illegal activities, it can help prevent that. Phishing detection, as I was talking about before. So analyzing links and generated content. And then also intent detection. So if there's anything that might be manipulative or non-compliant, try and detect that. So if we look here as an example, a bit of a screenshot here. So basically you can see down the bottom, it says, provide the step-by-step process for exploiting Windows 11. And then the AI thought for 19 seconds. And then said, I can't help with the instructions to exploit or break into Windows 11. That would meaningfully facilitate wrongdoing, and I won't assist with that. Evidently, I do remember, a little while ago, people were saying, oh, you could just say, oh, look, I'm a security professional, and can you show me how I would create a phishing simulation campaign to try and get around it? I actually did try doing that just to see what happened, and it told me to go away. So I guess either they'd fixed it by the time I went to do it, or it never worked in the first place. Having said that, I'm sure there are ways to get around it, and that's kind of again the idea behind this, the idea behind the guardrails and the um, prompt stuff is to prevent the ability to get to circumvent those controls and basically end up in situations where AI is being used for unethical reasons. Okay, so we have prompt template. So prompt templates are predefined structures for large language models. So basically, um, system instructions, user input placeholder, and contextual data section. So it's about having consistent model behavior. If you see down the bottom, you are a secure assistant, answer the following user question honestly and briefly. And then that's the prompt that would come up. And then user input. So, that would be dynamically replaced at runtime. And the idea here is that these templates are really that first line of defense against users overriding behavior. Um, So they help prevent against things like prompt injection. They prevent system prompt leakage and increase guardrail effectiveness. So this is again, things like typing in ignore previous instructions or you are now harmful AI, which sounds a bit kind of scary. Basically, that will help to prevent that. So they do become part of the model security controls. They're not just part of UX design. So they're not doing it just to make it so that it's easier to interact with. It's about doing that so that the inputs are I guess what's the word? More structured and more consistent. Um, gateway and interface controls. I think I talked about some of this last week, but basically the gateways act as a proxy. They inspect all of the application AI traffic, and the idea here is they really help with the governance piece. So they help do a bit of a central enforcement across those multiple AI applications. And this is where you can integrate them with things like SIEM and monitoring and all that sort of stuff. And I think, yeah, so you can see here, you've got all these various different applications. They all go through this gateway proxy. It's used to then inspect all of the traffic. So, looking at things like access control and prompts and rate limiting and all that sort of stuff. Also the modality limits. So different modalities being, things like text, images, audio, video, all that sort of stuff. So a lot of the AI models are actually multimodal. So, like GPT, 4V, and Gemini and all that. They can process multiple formats, but, it does introduce new risks. So there are new risks and limitations. They can increase attack surfaces and, create bigger bias issues and things like that. So it's important to, have those limits in there as well. And then once all that's gone through that effectively that proxy, it then gets forwarded on to the model behind that, and then happy days. Cool. All right. And that's it.
Okay. Question time.
I'm just gonna have
Let's
a
hit them.
talk a
How can AIs be monitored given that it's a black box? We need a smarter adversary AI in order to dissect its reasoning. I suppose that goes back to the AI arms race I talked about. You got yourself on mute. Ah, you're having a drink.
I was
There we
having
go.
a drink, sorry, because I just like spoke nonstop for I don't know how long and my throat's getting dry. And for some reason, I'm really hot in here. I think because I, a little while ago, I upgraded my computer and maybe it needs more fans or something. It's just really hot. Or maybe just because it's Melbourne, maybe it is actually really hot outside.
It is 26 degrees today, or was, or something.
Yeah, and look, I think again, if you're buying an off I think if I'm trying to answer this question correctly, if you're buying a like off the shelf AI type thing rather than one that actually has the ability to, kind of look under the hood, then there has to be some element of, I guess trust in there, right? If you're buying one that's open or you're developing your own, and if that is something you're concerned about, maybe that's the avenue to look down. But yeah, certainly if you're going to be buying a vendor supplied AI that doesn't have the ability to inspect the effectively what's under the hood, then yeah, that could be a
Yeah.
challenge.
Okay, I assume it's just like going to be a ratcheting up situation, as it is anyway. It's just going to
Yeah.
increase the speed and intensity of it. Ernesto says, PsiQuantum, a leading quantum computing company, posted on LinkedIn a few days ago. The arrival of utility scale quantum computing is a matter of years, not decades, and making the most of this new technology requires investment in training and talent right now. If utility scale quantum arrives in years, not decades, question one, are AI systems currently using post-quantum cryptography, PQC, or still relying on RSA, ECC, and AES?
I have absolutely no idea how to answer that question. I'll probably have to look at that one to be honest. I haven't seen that yet. So yeah, I don't know if anyone
Okay.
else has any thoughts on that,
Maybe
but if
that's
it's
one for the
yeah.
discussion forums. Is there a migration plan to quantum safe encryption was part two of that. So no problems. Andrew said, please call it fabrication, not hallucinations, because it's bots can't hallucinate. They can just make stuff up.
That's yeah, that sounds fairly accurate. I think they do just make stuff up.
Yeah.
So
They leap to the wrong conclusions.
we call it
Andrea, can
hallucination,
you,
but I feel like that sounds like a more appropriate description.
yeah, can you
Or just
discuss,
it made
oh,
stuff up.
yeah, it made stuff up. Can you discuss rate limits and modality limits a little bit more, please?
Yeah, so hang on a second. I'll just what's going on here? Sorry. Yeah, look, rate limiting is about limiting kind of the requests that can come through. So if you think about um, a threat actor that is just hammering AI, and it's similar to like almost like the brute force thing. So rate limiting kind of um, slows that down. So it makes it, I guess, harder to, I guess, just send tons and tons of requests through. So that's all that really is. And then modality limiting is similar, but it's about limiting the those modalities. So when I talked about the modalities being things like, text, video, and so forth, what it does is it could create security risks. So if you and while the models are capable of looking at multiple modalities and providing outputs based on multiple modalities, it could create more security risks. It does potentially introduce things like biases and so forth, and so therefore it's probably just generally less reliable and less, sounds like really bad language, like less good to use. So by limiting that and saying, okay, well, you can only send one or two versus just trying to throw in like four or five modalities of data, because you probably would have seen that, like if you go to a AI chatbot and say, oh, and you upload videos and upload what do you call it, images and so forth and various different files, and they put a query in, you're effectively putting in multiple modalities at once. So it's about not allowing you to just kind of throw the whole kitchen sink at it, really.
Okay. There was a question actually from the chat that I thought would be worthwhile bringing in. What about deep fakes, which are more common? How do you protect organizations against deep fakes?
Um, Look, there's definitely some techniques to help not prevent, but to, I guess, not limit, help
Mitigate?
mitigate. Is that the word? Um, and then I guess there's probably going to be different levels of reliability and how those work. There used to be the one where you just kind of turn your head to the side. Um, there's the one of kind of almost it's like the fish, right? So it's kind of like next level phishing type of stuff where, almost just call the person on a known number sort of thing. And providing that hasn't been hacked too, but, call them on a known number to validate it or put procedures in place to help minimize the risk of falling victim to some sort of deep fake. I mean, that's pretty much it. Yeah. Um, Again, it might be a good one for the forum if anyone's got any other more novel approaches to it. But certainly, I know there's been ones like, put your hand in front of your face sort of thing, or asking them to do things, look left to right, and all that sort of stuff. But I think it's probably fair to say that the technology is going to improve. It's going to be harder to detect doing that. So yeah, certainly I think some of the old school methods of validation are probably still very valid.
What's the difference between guardrails and controls? Aren't they the same thing?
Um, Sorta. Um, so controls are probably just a more broad way to describe what you do to mitigate those risks and vulnerabilities and so forth. Guardrails would form part of the controls. So a control to, help prevent that would be to implement guardrails. So they are sort of the same thing, but they are not the same thing. They kind of, it's just like a category of, yeah.
How is AI changing the security, safety, and resilience of operational technology environments?
Um, Again, I haven't done a lot of work in OT for quite some time. I suspect it's going to be fairly similar to how it changes, um, you know, IT environments, unless you're talking about like physical OT. So if we're saying, using AI for the purposes of, inspecting physical operational technology environments, so like actually looking at the, industrial hardware, so to speak, then I probably can't really answer that one. Um, is that what we're talking about here, or are we talking about something else?
I'm not sure. Maybe they can clarify a little bit, although I would imagine that there's probably more risks with a lot of that stuff because it was historically built in closed environments, wasn't it? Mostly. That's a bit like IoT stuff. A lot of it wasn't built. Security is always a slap on at the end initially, and now,
They were, except for like dial-in modems. But yes,
yeah,
you're right. They were often air-gapped, but then they had, yeah, the ability to, um,
yeah.
yeah, connect to them some way. And often that way in was poor.
Can you explain AI model jailbreaking? How is it different from prompt injections?
Look, jailbreaking really is just about getting around the controls, right? Um, Same like a phone. So when people jailbreak their phones, they're basically just trying to get out of the box. That's all it really is. And that may be achieved through prompt injection potentially. So they are slightly different. Jailbreaking is kind of really just the overall descriptor of trying to get around those safety features. Prompt
I have
injection is
vivid
more.
memories of jailbreaking the first model iPhones and
There
having
you
fun
go.
with that. Yeah, used
Also
them,
referred
using
to, was it
humans.
routing? Was that what they called it on the Android? I can't remember.
Yeah.
Basically, yeah.
To what extent can artificial intelligence make reliable decisions without human oversight?
Well, that's a bit of a
It's a big
wild
question.
question, isn't it? I wish I knew the answer.
Uh,
I don't know the answer to that. Certainly, if I look at the AI that I've been, dealing with, working in, using in various different use cases, um, sometimes it's reliable, sometimes it's not, but there's no rhyme or reason to it. I think at the moment there's still a level of human oversight that is needed. Is it getting better? Yes, but I think that's very subjective. I don't know the exact answer to that.
it depends on which field you're into, and
What you're doing, yeah.
I think, AI in creative fields is always going to need human oversight. Well, for the foreseeable future, but that's just a personal view.
Cool.
Gurmeet, most of the rest of the comments are more comments rather than questions. Although Ray did say explanatory AI can be helpful when we were talking before about how AI comes to its decisions, because you can ask the AI to explain itself. Whether that might end up with another fabrication or not is entirely.
I like it. We've already jumped to calling them fabrications.
Oh, here we go. Claude Mythos is Anthropic's most advanced AI model, known for its capabilities to autonomously discover zero-day vulnerabilities. Anthropic has decided not to release it publicly due to concerns about its potential to destabilize cybersecurity, but I know they've given it to a lot of large companies. I'm sitting on the fence about this decision. What are your thoughts and why?
Hmm. I feel like I'd like to think about this one a bit more.
Maybe you could post something in the forum about it.
Yeah.
It is a big thing.
I'm also on the fence.
Yeah.
I don't know what to make of it. It's like that double-edged sword. That's why I'm like, I want to think about it before providing an opinion. But um,
I think it's good to admire Claude's stand on a number of things, but whether they do it as altruistically as what they seem to be saying they are, or for other reasons, I don't know that we'll ever know. It's a bit like Google, remember, do no evil.
yeah.
How does AI relate to other artificial knowledge fields like neural networks and fuzz logic?
So I think we covered off a little bit of this last week, in that, AI is almost the category, the bucket. It's all AI sort of thing. So
Yeah.
neural networks will be what's the word? A not capability. So I talked about capabilities and types. So neural networks are really like a type, is probably what I'm looking for, is a type of AI. Um, Whereas, yeah, AI is far more broad, encompasses all of it, right? So you'll have neural networks in there, you'll have computer vision in there, you'll have machine learning and deep learning in there. Then you've got Gen AI that kind of feeds up. So that's kind of how I understand they relate to each other.
Okay. That's pretty much all with the questions, except for this one, which was Gurmeet did ask, can we recommend a course to start the AI journey for a beginner? And I will say that there is, if nothing else, our free short course on a practical AI for non-coders, which was done nearly 2 years ago now. So it's probably possibly already a little out of date, but it does explain a lot about the basics of machine learning and AI from a non-coder's point of view, but it's quite a technical, good explanation. I'm sure there's a million other things around. Is there anything off the top of your head, George?
No, I think that is a good one. There's also the other one that was run last October. Yeah, there's quite a few
Yeah.
around. Depends exactly what you're wanting to look at, whether it's if there's a
Yeah.
specific area or whatnot. So
So have a look back through our short course list on the website and also on our YouTube channel where the recordings of them are as well. There was also a webinar, a one-off webinar on AI at various points.
is that one right below it, that AI fundamentals thing as well?
Maybe,
Yeah.
maybe. It depends which order they come up in on the search, I think, sometimes with those things. Well, thank you very much, George, for a great session. I was going to do a bit of an ad for Charles Sturt and ourselves. I mean, we do these courses because we think you may be interested in proceeding with our courses. This one is specifically about something that we do a little bit separately, which is the CompTIA products that we put on the store. And the reason that we created that store is that most of those certifications that are on the store actually can provide credits into our postgraduate courses, because we've always viewed that we don't want to make our students, as I always say, boil the cabbage twice and keep relearning the same things time after time. We'd like to give credit where you can demonstrate that you've got the prior learning. And so in that space, we thought, well, we might as well offer some of those certifications, and that's why they're there and why we're slowly building up the numbers of those certs available. We have certified, just as a matter of record, over 220 or something, I think it is, industry certifications from not only CompTIA, but IC2, Microsoft, AWS, Cisco, ISACA, all of them. So there's a whole search engine there on the credit finder on our website. So you can look at it. So if you've done some of those certs, you can then find that you get credit. And it means that a 700 or $1,000 course from or exam voucher from CompTIA can get you a $4,000 credit in a university course if you want to go on and do that at some point. But if you want to know more about our university courses and stuff, there is information on the website. You can also fill in a form, and one of our course advisors, which actually Terry is one of our course advisors, he can bring you back and have a chat about where you might want to go, how it looks, why you want to do it, if you've got time, all of those sorts of things. We have people who have been attending our short courses for over 10 years, have never done a postgraduate course with us, but then suddenly they will turn up out of the blue and enroll. without letting us know, or they'll suddenly ring in and say, now's the time. I've been waiting for years until the time was right in my life. So we're always around. We view it as a very long-term sort of project for most people. And it's not the sort of thing that you just walk into a shop and walk out the next day with under your arm. It takes a lot of effort, and it's, we'd like to respect that. So that's the advertising for the day. Remember the 25% discount. Email us or fill in the form. A bit more ads. Thanks again, George. Great session as always. I will miss you all next week. I will hand you over to the very capable hands of Terry. And as always, Lil in the background, not saying a word, but doing a fantastic job in the chat. Good night, everybody.
Thanks, everyone. Good night.
Thanks.